Well, hello once more. As stated in the last video, we would crank up this video still on our single pricing unit, our SPU1. I've since discovered a couple of things that I'd like to show you. First thing we're going to do is I'm going to show you a little bit what goes on down in here. It won't be anything heavy and thick, just something I picked up from a video that was sent to me by Brendan. The video was not Brendan's, it was by Chris Cuff. Chris Cuff is a very knowledgeable individual. And when I see people who are knowledgeable, I know that people are knowledgeable like Chris and Brendan. I pay attention to what they say. Now, of course, Brendan will not necessarily agree with that statement. Sometimes, he's always saying, well, not that you're going to do what I tell you to do. But I always do. He doesn't think so. But we're going to go ahead and show you what I learned from Chris's videos. Then we're going to do some ripping and tearing. Oh, I know Brendan's saying, see, that's exactly what I'm talking about. I tell him not to do it and he does it anyway. But I always do it after giving it a lot of eyeballing and skull braining. I just don't start tearing things apart. You'll see. Let's go ahead and cover this first. Let's get a little closer. You'll remember in the last video I showed you how these relays, or not relays, but solenoids will go in and then they hit those little things back here. And let me see if I can get one around there. Yeah, like that. They come out and they hit that little thing and make it go out. See it? Well, let's go ahead and pop them all out. I think there's like 4 there. There's one there. There's another one there. And there's a couple on the other side. Let's get them all popped out and we'll come back. Now, I want you to check this out. Now, I've got, apparently there were 6 of those things. I've got them all, pushed up. They were down. And I've got them, now I'm going to have to pop it back up. They were down, and I've got them popped back up, like so. If I can ever get it up there. Come on, it's hard to do while looking through the camera. Let me try it like this. There we go. Okay. You see this little funny looking piece of metal right here? It's got a lip. That's called a ramp. And what happens is once these things go up and they're in that position, you put in your dime, your nickel, your quarter, activates the solenoids, pushes these things up. And the question is, well, how do they get back down after the solenoid is, de-energized? It goes back into its normal position. What causes these little things to go back down? Well, that's the purpose of this ramp. Watch what happens as this thing spins. Now, you keep your eye on the next one that comes around. Here it comes. Oh, come on, don't let me lose my light. There we go. Watch what happens as they bring it around. Now watch that ramp and that thing. See, that ramp comes down at an angle. You see how I flipped it back down? Let's do the next one. It's right now, it's riding against the bottom of that ramp. And as it comes down, the ramp gets lower and lower and lower. Causes those things to pop back down. Let me get my finger ready. Here we go. See it? Is that cool? That resets your solenoid. But anyway, what it does, if you take this ramp, a lot of people took this ramp and they bent it back. Because what this is doing is canceling out the money. Every time you press a song, after you put your money in, you press a song, this thing rotates around, slides down underneath this ramp, causes this to go that way, and keeps you from selecting any more songs than what you paid for. Once all these things have gone down, however many were popped up by the amount of money you put in, then that's it. You can push the buttons all day long. It won't do anything. This is the credit mechanism right here. And a lot of people, what they would do is to get this thing into a free play mode. Now, this is per Chris Cuff, and it makes perfect sense to me. They would bend this thing back. So when these things came around, they were not underneath that ramp. They would stay up the entire time. The problem was, once you bent this out of the way, yeah, you could free play this thing, but the latch solenoid that I showed you in that we just messed around with a couple of videos ago, the one that we got all clean and everything, that latch video stayed energized, and after a while it would burn out. There was something else I spotted in that Chris Cuff video, and that is that coming off of this right here is a set of contacts. another set right there. See them? There's a set there and there's another set down below. Get a little closer, maybe we can see both sets. Yeah, you see the second set down below it? Those babies got to be clean, but how do I get down in there? How do I get down in there to get that done? I could maybe get partial done. I don't think I would do a good job at it. They may not be working real well. I might be able to say, yeah, they're clean, when in fact they're not. So what do we do? Well, I'm going to show you what we did. This is where old Brendan's butt will be biting the seat again. All right, through the magic of my brilliance, I have determined that all I have to do, this is one unit right here, and it's held in by 2 screws. One there and one down below. Let me see if you can see that. I want you to see it. See the 2 screws holding it? And this spring. All I have to do is unhook this spring from this right here, take out these 2 screws, and that entire assembly in one piece will come out. And this is the solenoid that operates those contacts. Get over here. See, it makes them go in. Let me get my screwdriver to press it with. This makes them go in. The solenoid does. It pulls it in magnetically and opens and closes. It opens one set of contacts and closes the other when that happens. So I have to be very, very careful. But it will all come out in one assembly with the removal of 2 screws, and the screws are not adjustable, so I don't have to worry about, you know, getting them out of whack or anything. They go right back in the exact same position they were when I take them out. So let's go ahead and get that done. All right, we're going in for the kill, folks. We're going to loosen up. Make sure we got a good solid bite all the way to the bottom of the screw. We don't want to be stripping any screws here. All right, that's good. All right, we got lucky on that one. And this thing has come in so handy. The only problem is we got a very weak metal and it bends easy on the tip down here. Now this side's okay. No problem on this end, but this end is very weak. I've had to straighten it out a couple times. But it's going to come in very handy for us right now. You know, you try to use a pair of needle nose on that, you're going to screw up the spring. All you got to do is just hook this up here underneath that spring and get it a little better position, just like that. Then all I have to do is unhook it from the hole. It's going to take 2 hands, okay? But this little tool really does the job. The spring is disconnected. I just got it hanging over here, and the 2 screws are out. Now let's see if that whole mechanism won't just come up out of there. Now, by the way, what's holding this plate in right here that works on the, let me get it around here where you can see it better. That works with the solenoid when it activates. What's holding it there is that spring, but since I have the spring disconnected, it just kind of flops around a little bit. So let me wiggle this thing around a little bit. I should be able to remove the entire mechanism in one piece and get to those points. Yeah, see, they're already starting to come up. Let me work it with 2 hands and see what we can do here. Well, it won't come out entirely. The reason being that this black wire here is a very stiff, looks like a grounding wire of some kind. I don't want to take that loose. If I were to take that loose, the entire thing would probably wiggle its way back this way and up out of the way. And this thing here is in my way too, but mostly it's that wire. I just don't want to disconnect it. So, but we can move it up a little bit to where we can get to those contacts a whole lot easier on the top and the bottom. So let's take our little old brush and our little alcohol and let's see what we can do. You can see those things are really black. Look at that. Really messy. Well, it was a close call, folks, but we somehow pulled it off. We have everything back where it's supposed to be. Spring hooked back up, the 2 screws back in. And our contacts look a whole lot cleaner than they did. Let me zoom in here a little bit. They were all black and really mangy. Now they're fairly clean. And that's top and bottom. It's a whole lot better than they were. Now I took some cardboard strips. I cut them and I went and I put them between every set of points or contacts on this thing. I spent the last 30 minutes doing it. And scrub it up dub between them, you know, back and forth with contact cleaner. And you can see that there's, let me get the light out of the way, maybe you can see it a little bit better. You can see that there was still some dirt on those contacts even after all that cleaning, okay? But they're nice and clean now. But that's all we got off of them, so we did really good. Okay. Also, I've been spending some time oiling. We had a few problems that, you know, if it's mechanical, I don't care if it's metal to metal, it's going to have some kind of very slight, at least, lubrication. So over here on our cancel relay, let me get something to put underneath here so you can see what we're doing. There we go. Okay, our cancel relay, no more squeak. I went ahead and put a little bit of oil down there where these, you know, these rivets are acting as pivot points. Put a little oil on that little, looks like a nylon or some kind of plastic wheel that thing rides against. Put a little oil on this shaft, which is behind this flange, back in there. Took a little bit of dielectric grease on my finger, not very much, and just put a light film on this plunger. And now the entire thing works so much better. No more squeaking, no more drag, no more wear essentially. And then I went ahead over here and went to work on this part. Let me get something to set this on. This thing is really an awkward piece of equipment to work on when you're trying to show people something. There we go. Down in here where this thing was, there's a pawl. Let me see if I can get this up here high enough where you can see it. There's a pawl that catches this gear, that little pawl right there. It goes up and down and catches in the teeth that keeps the wheel from going back. See it? And what was happening is it was stuck up like that. It wasn't moving at all when this thing turned around. What it was supposed to do, let me zoom in a little closer. What it's supposed to do is as this thing, this credit thing goes around, it was supposed to drop in like that, and it wasn't doing it. And a little bit of oil. I put, this is all that shiny stuff there is dielectric grease, a very thin coat. And now she drops in very nicely, like it's supposed to. And that to what that was handled with was a little bit of oil up in that spot right there. All mechanical down in here. As long as I kept it away from the points right here, I'm okay. So that's all done. I kind of like the way that looks now. That baby drops in very nicely now, like it's supposed to. What that does, like I said, is it keeps the wheel from going back the other way. Okay, just like any pawl would. Okay, anyway, we went ahead and oiled everything that needed to be oiled without going bananas. Everything's back in the way it's supposed to go. And I think what we're going to do now, we're just about done with this baby. Except for the capacitors. I'm going to talk to Brendan about that. You know, everybody has an opinion as to one way or the other. We should replace them or not replace them. I don't know. I really don't know. These are old and they should be replaced probably, and I have the capacitors to do it, so we'll see what Brendan has to say. He'll contact me after this video, I'm sure. What we're going to do now is take this pipe cleaner. We're going to go ahead and clean these contacts on this plug. And I think, according to Chris Cuff, one of these is ground, and then you've got nickel dime quarter, which activates your three solenoids down here, your nickel dime quarter. And then, of course, this is a tube or a plug. No, this is a big plug. That's a great big old plug. And that plugs into there, probably from the Tormat. I haven't even checked it out yet. We're going to go ahead and clean all these out also. And as soon as we get done with that, I think that's going to be about it. I might go ahead and take this and give it a good scrub. Maybe clean up the wires and the connector or the plug a little bit. Looks kind of mangy a little bit. I'm not going to do a whole lot of more ripping and tearing on that. I don't want to give Brendan a heart attack. Poor guy, he's probably up there saying, I can't believe he did that. I still can't believe he did that. Okay, let me go ahead and get some alcohol, get this clean, and then we'll set this aside and then maybe move on to something else here. I need to get some tape on this. This is all they had holding this whole thing together was this mangy old cloth stuff that came apart as soon as I touched it. We'll go ahead and wrap this on up with some nice electrical tape, make it a lot stronger. Well, that's it. One layer is all it takes. You know, I've seen some where someone put 75,000 layers of electrical tape on there thinking they were really accomplishing anything. You're not. You know, one good layer all the way down, all the way back is all you need. Works great, still flexible enough to move around. And, you know, it's not like you have to pull on this thing 50 times a day or anything. At long last, the old select-o-matic mechanism is back on the bench. And it's kind of late right now. I've been working all afternoon. So I think what I'm going to do is pick this up tomorrow morning. Well, I'm sorry to say we're not going to pick it up after all. Something has come up. Something has come up from one of our subscribers named T-Jet. And he also goes by T-Jet 737, so I'm not sure which is which, but it doesn't matter. He gave me some information about those copper springs that I put in the keyboard a while back that we were having trouble with, if you'll recall. I finally said I figured it all out and it looked good, and he contacted me and he said, you know, it did look right, however, it's not right. So he sent me some photographs of the Seeburg jukebox that he's working on, and I compared that to what I had done to our keyboard, and now guess what? Our keyboard is back out of our jukebox. Didn't expect this. But you can't go to the next step until the first step is actually complete. I thought it was complete. It wasn't complete. We're going to work on it. Those copper springs, you remember, were down in here. We have to take this bar off and look at them one more time. So let me get all these screws out once again. Now he claims, let's get the light down here. He claims that when he opened his up, he has basically the same kind of push buttons that I have here. And we're kind of doing this the opposite way because I don't want to take this metal off after I got it all hooked up. We put our, let's just take this one out. You'll remember that we put ours standing up. Let me focus down in there. We put ours standing up like that. Now he says that's not right. Let me get my tweezers. He said they should be down in there flat. If I can find my tweezers in the thing there. There we go. The pictures he sent showed these things. Come on, where are you now? Okay, we're going to have to take two of them out, I guess. Alright, let's try it again now. He said that they belong flat at the bottom underneath these plastic keys, with the hooked part facing the keys. So instead of vertically the way I had them with the backs against the silver like that, see, I had them essentially, boy, this is kind of tough with that hood still hanging in there, but essentially I had ours, initially I just had it flat like that, okay, on the opposite side. He said what has to happen is these things go in like this, and then the backs of the keys fit on top of them, like that. Well, that makes quite a bit of sense when you think about it. Easy to install. I just couldn't figure out how they would make these so difficult for someone on the assembly line. It would have to be fairly simple. So let's set this thing in here. I keep getting this thing out of the camera, sorry about that. Let's set this thing in here like so. Down in there flat. Oh, this is not so easy. Let me get it in position, then I'll come back. Let's try this again. This is the way I had them in there originally. See how they're vertically standing up? They're standing up vertically with the back of the clip against this chrome section. According to the T-Jet, whose name is Tony, Tony says they need to be flat, and that's the pictures he sent with me to me with these things flat. The backs of these things are now flat against the bottom, with the keys sitting on top instead of the back being against this chrome wall. See the difference? Vertical and just flat down in there. Well, he said once you get them all in that position, and then you set your key back down on top like so, and then you put your bar on and clamp it down, he said it'll work a whole lot better. Well, I'll tell you what, I've got them all laying flat now, and you know, this pretty much tells me this is probably the correct way, because look, they fit exact. There's no movement or anything. They just slightly move left and right, but they do not move this way. They fit down in there exactly the way they're supposed to fit. See it? Now I have the keys sitting on top of them already over here, and we'll go ahead and set a couple of these in to show you what I'm talking about. There goes one, and this is 9. And 8. See how they fit nice down in there, right on top of them? We have put a fresh layer of grease all on there because a lot of it got rubbed off in the process here. Let me see, a little bit could go right there, I suppose. Alright, all the way down, we're looking good now. Now we'll just go ahead and put this baby on and see what happens. The bar's back on, and they have the same kind of action they had before. If I push from the back, there is a slight difference though. I now have a little bit of spring action underneath each one. Over here they're a little bit better. See it? They sort of spring back out a little bit. I probably could have spread those copper things apart a little bit, but I didn't want to do that. If I break one, jeez, you know, where would I get another? So I don't know. They seem to have a little bit of spring action to them. I think that's the way they're supposed to be. And unless anybody has a third idea, we'll go ahead and leave them like that. Either way, I think they're in there nice and secure. They're not going to go anywhere. And we'll see. Now see, these over here have a little bit less spring action. Now the ones on the end are pretty springy. I really appreciate Tony T-Jet pointing out the problem we had with those copper clips that go in the buttons. Had he not done so, I may have got almost the entire jukebox put back together, or all of it, and then someone finally popped up and said, oh, by the way, you got to go back and tear it all back apart again and put those clips in right. Well, he came along at the right time. It was easy to get that keyboard out. It was a pain in the butt, but it was still easy because I knew exactly how to do it. Time consuming, I guess, is the word I should use. So thanks a lot, Tony. You're a good feller, and apparently that's the way it's got to be. It is time to change out the selenium rectifier on this mechanism, selectomatic mechanism, and we're going to remove the selenium rectifier and replace it with a diode, a 1N5604 diode, which is a 3 amp diode. But I wanted to point something out here that this has come up once before in a video series that I did on a 1953 RCA television. And now here it is, years later, it's come up a second time. So I knew what it was as soon as I saw it, fortunately. And those of you who watched the series on the 1953 RCA restoration, you may remember it. It was a number of years ago. What we have here is a rectifier with it just shows an anode on the left, cathode on the right. But the polarities don't match up properly. An anode is positive and a cathode is negative. But they have them just the opposite. They got the cathode as a positive and the anode is a negative. It's supposed to be the other way around. What do we do about that? Well, I'll tell you what we do about that. We're going to go ahead and remove this, replace it with the diode, ignore the two symbols because way back when, that's the way they did it. It had something to do with current flow. You know, it flowed from negative to positive, more so than the actual polarity of the selenium rectifier itself, or the diode that we're going to replace it with. So use the symbol on the schematic. You know, don't worry about these plus and minus signs. Make sure when you put your diode in, when you have something of this nature, no matter what it is, make sure you're in this case, the cathode will connect to the resistor, okay? And the anode will connect to the two wires, one that goes to the trip solenoid and the other one that goes way down here somewhere. So there'll be two wires on the left connected to the anode, one wire on the right, or actually a resistor on the right, connected to the cathode. All right, there it is. She's out. All this thing had was, like I said, a resistor soldered to one terminal end of it, and the other side had two wires. And by the way, this resistor, I had to replace this resistor right here. It's supposed to be 120 ohms. Let me see, get a little closer. That resistor is supposed to be 120 ohms. It was reading 181.5. Anyway, it's gone. We got a nice new 121 ohm resistor in there. It's supposed to be 120, but it's, you know, 1 ohm over, no problem. Anyway, let me tell you a little something about selenium rectifiers. You know, some folks think every time you replace a selenium rectifier, you need to add resistance to replace the resistance that's lost in the selenium rectifier when you remove it and then you know, that resistance is not replaced by a diode that you put in you know, in replacement for the selenium rectifier. That's not always the case. You don't always have to add resistance for the lost resistance in a selenium rectifier swap out. If it's in the power supply, yeah, you definitely want to make sure that the power supply ones will be a lot thicker, usually a lot bigger, unless they're in like a battery radio. Then they'll be very small, and even then it becomes even more critical that you do replace the resistance in the power supply, especially when you're dealing with those little battery radios that have, you know, 1.5 volt or 1.5 volt filaments in the tubes. You know, it doesn't take but a half a volt extra to blow those poor little old filaments out. So yes, you want to make sure you replace the resistance lost after you've removed the selenium rectifier. And then of course you have to monitor that voltage when you bring up the power on a variac to make sure you have enough resistance that won't, you know, that'll prevent the blowing out of those filaments. I learned my lesson the hard way. I blew out 2 of them before I realized what was going on. Anyway, in this case, what have we got? Do we have to add resistance? No. I'll tell you why. It's, number one, it's not in the power supply. It's over here, okay? And it's only got 25 volts coming to it. And it's connected to the trip solenoid on the mechanism. 25 volts. So what little resistance you're going to find in here, well, you know, probably won't raise the voltage to that solenoid more than 3/4 of a volt by removing it, you know, by replacing it with the diode. But let's say it goes all the way up to a volt or a volt and a half. Well, so what? You know, we're dealing with a heavy-duty wire-wound trip solenoid that a volt and a half will not really negatively affect. Okay, a volt and a half extra what it used to have. So I am not going to add resistance after we replace this with a diode. It depends on how it's used in the circuit. Here's that trip solenoid I was telling you about right here. That's on the schematic. Pretty heavy duty, little sucker. Trust me, another volt or a volt and a half won't affect it one bit. And we now have the diode installed on the circuit board. I've got the cathode end connected to the resistor. You can see back here's the resistor, just like in the schematic. The anode end is connected to the 2 wires, this one and this one. And I raised it up off the board a little bit. This is a 5406, a 3 amp diode, and it'll probably generate quite a bit of heat. So you don't want to press it right on down next to the board, okay? Give yourselves a little air space there. You know, on the terminal board, you don't need to press it right on down. That's pretty heavy wire, pretty heavy duty little baby. So remember that now. Just because it's a selenium rectifier, it depends on how it's used as to whether or not you need to replace the missing resistance. Now, all of that being said, if it makes you real nervous and everything, go ahead and do it. It's your project, your radio, your jukebox, your whatever. If you want to do it, go ahead. I'm just trying to point out that it's, you know, and depending on what it's used for, it's not essential. Go for it if it makes you nervous, but always do it in a power supply, especially a battery operated radio. Always do it. If you don't know how to do it, get with somebody that can show you how to do that. Well, that's it, guys. We're going to go ahead and wrap this up. It's gone way longer than I expected and way longer than I wanted. I wanted to get to the amplifier. We're obviously not going to do that this time. And I also wanted to do a little demonstration of this little spot blaster. And it's a spot blaster, not a sandblaster for a large area. Although I guess you could use it for that if you wanted to take forever. I wanted to do both. Hopefully we'll be able to do that next time. Now look, if you don't hear from me for a while, it'll mean because I'm changing ISPs. Our cable guy came out and looked at our cable. I kept telling him it's going up, down, up, down, up, down all the time, 30 times a day. And his answer to that, you're not going to believe this, his answer to that was, well, the frequency changes with the temperature. So you out of your mind, you know, get out of here, you bother me with that crap, you know. So I was supposed to say, oh, okay, no problem, I'll live with the internet going up and down 30 times a day. No problem, everything's fine. Yeah, wrong. So I may have to go back and try to get AT&T to cooperate this time. You know, the way AT&T drags their butt, it could take a while. Hopefully I'll be back up by Christmas. But it is the Christmas season coming up too, so everybody's got other things to do. If not, then you won't see me till after the first of the year, I assume, depending on when AT&T, if they you know, decide to go ahead and hook me up. I don't want the DirecTV, but I'll have to take it. I'll have to sign a lousy 2-year contract, but that's the way it goes. You know, that's life in the fast lane nowadays, guys. There's no sense of griping about it, or, you know, complaining about it. Just get it done. So that's what we're going to do. I'm going to try to get just the internet, but if you don't hear from me until after the first year, that's why. You know, I'm in the throes of switching everything over. Hopefully I'll have good luck. So until next time, I want everyone to have a Merry Christmas if you celebrate Christmas. If you do not, have a great holiday season, okay? This is John.